Welcome to Derivatives Lesson 9, Derivatives of Exponential Functions and Logarithmic Functions. This is going to get complicated. I'll try to go slow. Probably not going to happen. Let's get on. Let's get moving. We got lots to do before Thanksgiving. Alright. F of x equals e to the x. What does f prime of x equal? I would like you to use the definition of a derivative to find out what f prime of x is. You know, the limit as x approaches 0, all that stuff. Alright. Pause and... Alright, I've done the first two steps so far. E to the x plus h minus e to the x all over h. The limit as h approaches 0, and if you replace, you're going to get 0 over 0. So what I did is I rewrote e to the x plus h as the product of e to the x times e to the h. Okay, when you have the same base, you add exponents. So I just kind of factored that out to that. And hopefully by now you're seeing a special limit going on there. Let's factor out an e to the x in the numerator. So we are trying to find the limit as h approaches 0 of e to the x times e to the h minus 1 all over h. Hopefully you can recognize that this right here, the limit as h approaches 0 is 1. So our end result is f prime of x equals e to the x. This function, f of x equals e to the x, its derivative is exactly the same thing, e to the x. How about if you have some function of x that is e to the g of x? What we're going to do is we're going to use the chain rule. First of all, f prime of x is going to equal, okay, what is the derivative of e to the g of x? Well, we just learned out that it's e to the g of x. It's its own derivative. But the chain rule says e is the outside function, g of x is the inside function. What is the derivative of g of x? Sure thing, it's g prime of x. So f prime of x equals g prime of x times e to the g of x. Let's go ahead and put this funky thing into practice. Ready? Here you go. If the function is e to the 2x, what is the derivative? Well, what is the derivative of the exponent? Derivative of 2x is 2, so 2e to the 2x. Okay, how about e to the 2x minus 6? Okay, take the derivative of the exponent 2, e to the 2x minus 6. Alright. Next one, e to the sine x. What is the derivative of sine x? That's right, it is cosine x times e to the sine x. Okay, how about the derivative of e to the 3x squared minus 5x? Take the derivative of that exponent, 6x minus 5, that expression times e to the 3x squared minus 5x. Oh no, look at this one. The exponent is a product, so you're going to use the product rule to take the derivative. So let's see here. 3 times the derivative of the first function, 3x is 3, multiplied by the second, 3 sine x, plus 3x times the derivative of sine x, which is cosine x, multiply all of that times that exponential, e to the 3x sine x. Whew. It's quite a mouthful, isn't it? Let's go ahead and move on. Okay, what if you're given an exponential function that doesn't have e as a base? So b is going to be some constant. Well, we're going to do some algebraic shenanigans here. We should know that b equals e to the ln of b. Those two functions undo each other. So we're going to replace this b right here with e to the ln of b. So f of x equals e to the ln of b raised to the g of x power. Okay, what happens when you raise a power to a power? That's right, you just multiply those exponents. So e to the ln of b g of x. So what is f prime of x? Okay, take the derivative of the exponent, just like we did just a minute ago. This ln of b, ln of 6, ln of 4, ln of 72, that's going to be a constant. So we'll just leave it out there, ln of b. What's the derivative of g of x? G prime of x. And then e to the ln of b g of x. Let's go ahead and clean this up. So the natural log of the base times the derivative of the exponent, and this is just b again. Let's put it back to its original form, b to the g of x. So the derivative of any exponential other than e, take the logarithm of the base right there, multiply by the derivative of the exponent, and then multiply that all by the original exponential. Here we go. How do you do that? How do you put it into practice? F prime of x equals, take a natural log of the base, ln of 5, multiply that by the derivative of the exponent, 2x plus 3, and then multiply by the original exponential, 5 to the x squared plus 3x minus 4. And you were asked to find f prime of negative 4. So that's going to be the ln of 5 times, let's see here, negative 8 plus 3 times negative 5 times 5, let's see here, negative 4 squared is 16, minus 12 minus 4, 5 to the 0 power. So f prime of negative 4 equals negative 5 ln of 5, which written decimally, I do believe, is negative 8.04719. What a mess. Let's keep on going. Alright, if f of x equals ln of x, I'm just going to flat out tell you right now that the derivative is 1 over x. We'll talk about that later in class on how to find that derivative. What about the derivative of f of x equals the natural log of some function of x, g of x? Use the chain rule. Alright, so here we are. We're going to try to show you how this is going to work. Alright. F of x equals the ln of g of x. Okay. F prime of x equals, okay, the natural log of x, the derivative is 1 over x, so the outside function, take care of that derivative first. The outside function is ln of x, so that would be 1 over g of x. Now we have to multiply that using the chain rule. Okay, what's the derivative of the inside function? G prime of x. So f prime of x, the derivative of ln of g of x is g prime of x over g of x. That will always be the derivative of ln of g of x. The derivative of that inside function over the inside function. Alright, let's go ahead and put that into practice. Okay, first example. The ln of 2x plus 1. Okay, what is the derivative of the inside part there? What is the derivative of 2x plus 1? 2 over the inside part, 2x plus 1. Okay, the ln of tangent of x. What's the derivative of tangent of x? Secant squared of x all over tangent of x. And I think we can fix that around a little bit. 1 over cosine squared x divided by tangent of x. 1 over cosine squared x times cosine of x over sine x. Cosines will cancel out there, and we'll be left with 1 over cosine x sine x. So the derivative would be secant x cosecant x. Yeah, that's pretty crazy. Alright, the next one. The derivative of the inside, 40x to the 4th minus 6x squared plus 6 all over 8x to the 5th minus 2x cubed plus 6x minus 1. Alright, let's look at something just a little bit crazier. We're going to rewrite this as the ln of 3x plus 2 minus the ln of 4x minus 2. Alright, go ahead and take the derivatives of both of those and come back. Alright, there's a derivative of both of those. Now get a common denominator and simplify to get your final answer for the derivative of this function here. Your final answer would be negative 14 over the quantity 3x plus 2 times the quantity 4x minus 2. Alright, the next one, ln of tangent cubed of x. What you really want to think of is the ln of tangent x cubed. That is really what's going on, tangent times tangent times tangent. Remember the properties of logarithms, we can move that exponent down front. 3 times the ln of tangent of x. So what is the derivative of tangent x? Secant squared. 3 out front from this 3 right here, all over tangent x. Hey, I think we just had this a couple of screens ago. Because we had it a couple of screens ago, I'm not going to explain to you why it is 3 secant x cosecant x. And then for the last function, I'm not actually going to go over it right now because I'm running out of time. So we're going to continue this lesson 9 with lesson 9.1. It'll be a continuation, so you're going to have to go over to that one. So actually this will conclude lesson 9, derivatives of exponentials and logarithms. I'll catch you on the flip side.